All right, here we go. This is the fourth part of this. We got two more to cover after this, and we'll be done. All right. This is conditional probability. That is probability based on something else or a condition already happening. There is a famous problem about that, and that's this Monty Hall problem. You can click on it, and it should take you there. If not, you can Google it, and you can try it. It's a pretty neat problem. If you look at it and you give it a try, it'll give you an idea of what this is about. All right. So this is called conditional probability. All right, it's finding the probability that an event will occur given that another event has already occurred. All right, the probability of event B given A is written as this: the probability of B given A. All right, this means the probability that B will occur given that A has already occurred. All right, so conditional probability, our example here. We have this table that shows students, and they're broken up by their gender, males and females, and they're also broken up by their college that they attended. So these were 2-year college, this is 4-year college, and this is grad school. All right, so the way you do this, the easiest way to do this is this. What's the probability that you will choose a female given grad school? All right, so what you do is you circle whatever this is, the grad school. These are the only numbers you can use for this problem. Okay, those are the only numbers that you can use. So we want to know what's the probability that you choose a female given that you choose only from the students that are in grad school. All right, so how many of those are female? Well, 1,954. Out of how many total are there? Well, here's where we got to just add these two together. All right. So adding together 1, 3, 4, 9 plus 1954. And I get 3303. And then you can go ahead and divide that out. So 1954 divided by our answer. And that gives us about 59%. So it's approximately 59%. So 59% chance that you will choose a female given that you're only picking from the people in grad school. All right. So now our next one. All right, so if I erase this now, because now we're doing something different. All right, we want to know what's the probability that you choose a male given 4-year college. So now we're looking at these numbers. We can only use those numbers. So first thing we want is the male. All right, males, there's 4,000. Okay, so again, probability that male given 4-year college. All right, so males, we have 4,324. Over our total. So again, we got to add those two together. So adding them together, we have 4324 plus 5517, and that gives us 9,841. Now we just got to divide this. So again, we're going to do 4324 divided by our answer, and that gives us approximately 44%. So approximately 44%. Again, you want to round these to the nearest whole percent. All right, that was that one. All right, now this last one is a little different because now we want to know what's the probability you choose a 2-year college student given females. So now we can only use this column. All right, we can only use those numbers. So we want the probability that 2-year college given female. So now we're only using females. Of those, how many were 2-year college? Well, 2,462 divided by, and then we need the total. So again, we just add them up. So I'm going to do 2,462 plus 5,517 plus 1,954 and enter, and that's 9,933. So now we divide it out. So 2,462 divided by second answer, enter, and we get it's approximately 25%. All right. So that's conditional probability using a table. That's how you do it. All right. So you have a U-try to go ahead and you can do that. All right. I'm going to skip example 2 because it's just the same that we just did. So I'm going to just skip that. And we are going to need this formula. All right, we're going to need this formula for probability, for conditional probability. So this is the formula you're going to use. This is the probability of B given A is equal to the probability of A and B divided by the probability of A. Okay. So using this formula, it says what's the probability that a customer pays their bill online given that the customer is male. So we want the probability that they pay online given male. All right, so the probability of A and B, all right, so that's the probability of A and B, so the probability that they're male and pay online over the probability that of A, which is male. All right, so the probability that they're male and they pay their bill online, all right, so male and online is 12 out of our total, which is 50, divided by the probability that they're male. Well, male, we got 12 and 8, which is 20 out of 50. All right, so again, I'm just using the formula. So now we got to do keep, change, flip. So I get 12 out of 50 times 50 over 20. The 50s cancel out, so it leaves me with 12 over 20, which is 6 out of 10, which gives me 60%. So it's approximately, or it is 60%. All right, so that's how you use the formula. All right, so I'm not even going to do the second one, save some time. So you can do the U-tries. All right, do those 2 U-tries, and we're not even going to do the tree diagram. All right, so that's it for that section. So I'll give you the classwork worksheet to do for that section for tonight.